Many individuals frequently approach me with a query. How does one become a DevOps engineer? They are curious about the essential tools to learn, the best resources for education, and more. It's now the moment for me to provide a comprehensive roadmap for those who want to become a successful DevOps engineer. Hi, my name is Imran Afzal, and I've been working in IT field for over 20 years. I have almost a million students worldwide and have many best-selling and highest rated courses online. I earned my bachelor's from Baruch College and my MBA from New York Institute of Technology. I bring you this course which will provide you almost everything you're looking for to start your path in DevOps. This course starts with Introduction to DevOps, then it's practices, then we go into the DevOps lifecycle, and the best part is we cover over 20 tools that are used in DevOps field. My team has worked endlessly for many months to bring you this course, so please give it a shot. I'm very confident that every minute spent on this course will be well worth it. Hey folks, welcome to my course Introduction to DevOps. I have created this course for people like yourself who are looking to become a DevOps engineer and you are looking for answers as to how you could become a successful DevOps engineer. So please, I request you to spend a few minutes with me and we'll go over what am I covering in this entire course. I have broken down this course in 5 different sections. Section 1 is about introduction, where we will cover what is DevOps, what are the pre-DevOps challenges before DevOps was born, what were the challenges, collaboration of teams, history of DevOps, what benefits DevOps offer, why it is so important to learn DevOps. And when we are covering benefits and importance, then I will definitely cover some of the drawbacks that DevOps has. Then moving on to section 2, in which we will cover all the practices and services that are included in DevOps, such as continuous integration and continuous delivery, in short CI and CD. Then situational awareness, configuration management, infrastructure as code, microservices, monitoring, logging, and feedback. And of course, the last one is collaboration. These are all the services that are included in DevOps, and we will learn them. Then section 3, what are the different phases of DevOps lifecycle? Very important topic, and we'll cover from a very beginning discovery, how discovery and planning happens, how a code is written, and then the code is transformed into building a software, and then how the software can be tested and released, and then how it can be deployed, operated, and monitored. These are all different phases of DevOps lifecycle, and we will cover one by one. Moving on to section 4, which is the most important section of this entire course, where we will be covering all the tools, or I would say most of the tools that are used in DevOps. Starting with ServiceNow, Slack, Microsoft Teams, Jira, Confluence, programming languages, Jenkins, Git, GitHub. In addition, we are also covering GitLab and GitHub Copilot. Nexus, Docker, very important tool. Then Kubernetes that actually manages that Docker container. Ansible, the configuration management tool, Puppet and Chef. Shell scripting, Terraform, Selenium, Mabel, and X-Ray, Mural, PagerDuty, Splunk, Dynatrace, Datadog, Prometheus, Nagios, and system administration. Now you're probably thinking, really? Yes, I am covering all these tools. What are these tools? How you could download, install, configure, and all its demo so you could learn everything about these tools. Then the last section is about future of DevOps and becoming DevOps engineer. That's where we're covering transitioning to DevOps engineer role from all the different roles that you're in. How can you do that? Then the future of DevOps, DevOps job responsibility, what you should expect once you become DevOps engineer. Engaging in DevOps community forums, why it is so important. And the last one is your resume and interview tips for you to become a successful DevOps engineer. Now you ask yourself, is this the right course for you? In this video, we will cover the introduction to DevOps. But before we go any further, let's look into what exactly is DevOps. DevOps stands for, or it's in a short form, it's a development and operations. Now, development and operations are two separate teams that can often be found in bigger companies or bigger corporate environments that have, I would say, approximately 200 plus employees who actually build their own software to support their own workflow. And the operation teams are the ones that deploy that software and support that software. All right. So Wikipedia, if you search online and type it, what is DevOps? The Wikipedia says it is a methodology in the software development and IT industry. It is used as a set of practices and tools. DevOps integrates and automates the work of software development and IT operations as a mean for improving and shortening the system development lifecycle. It's very simple and straightforward. Now, if you find this definition a bit confusing or hard to understand, then let's make it more simpler. So, DevOps is a collaboration of development and operations team. So that's the very first thing that you need to understand, that development and operation teams becoming together as one team. All right. So now what's the purpose? For the improvement of designing, development, and delivery of the application or the software that is being built to support the company's workflow. That's a very simple way to define DevOps. In this video, we will cover the pre-DevOps challenges, issues, the challenges that existed before DevOps was introduced. The very first one is the traditional way of running software development and delivery infrastructure, meaning there were a development team working independently, there was an infrastructure team or operations team working independently, and there was a lot of issues in between them. There were long and repetitive procedure until the software package passes the QA test, and that causes lack of communication. And there was a lack of new strategy for the software development and delivery procedure. Because of all of that, there was a huge gap between the software development team and the IT operations team. And by the way, the development team consisted of together as a development program or QA or designers, and the operations team consisted of all the people who support the infrastructure or compute. All right, let's visualize it. So this will have a better understanding why we needed DevOps so badly. On the left hand side, we have developers or programmers in a company, let's say XYZ. They are responsible to write a code. They write a code maybe in C++, Java, Python, or in any language of their choice or the language as per the policy of the company. Then they convert that code into a software executable or ISO image, and then they passes that software to QA team to test that code. Now the QA team will take the code or the software and install in the QA environment and test it. Now as they are testing it, the developers or programmers has nothing to do but wait. Now that is, of course, as they're waiting, they have nothing to do, that costing money to the company.
And of course, if the QA team rejects that code or rejects that software, it goes back to developers to rewrite the code and fix it back and forth, back and forth. But let's say after a lot of back and forth, it passes it, and now it goes to the system administrators or operations team to deploy the code. Now, there might be a possibility where there's an issue with the software and it causes some kind of memory leak in a production environment. So it sends it back to the QA, QA sends it back to the developer. Again, it it actually creates huge gap. It takes a lot of time. So let's say if the code gets deployed successfully, now that code or that software is released to the end users. Those are the end users who actually gonna run that application. Now, if you are an iPhone user or Android user, you probably noticed that many times that Apple or Samsung will send you updates. Now, have you ever thought what those updates for and why do they send it? It's because they found a bug in the newest released software or newest ISO update. That's why they send you that patch update so you could fix it. Now, within the company, that application or software goes back to developer so they could fix the bug. So that is why the DevOps became so popular. So we could eliminate the repetitive cycles of these software going back and forth, and to save time and to deliver the best possible software or application for the company. In this video, we will cover the collaboration of the teams that come together and makes the DevOps team. So we will start with the devs team. Now, please know the dev team does not only includes the developers or programmers. Those are the people who actually write the code, and they write in different languages and create the software or the application to support the workflow. There are also people like front end engineers or designers who actually design how the application portal or the front end will look like. There are also quality assurance people who actually involved in testing that application. And sometimes there are specific people who just do testing for, or they are hired just to do testing for that specific application. Okay, in bigger environment or in bigger companies, these are the actual team that work independently. There are a bunch of people working together in each of these teams performing their own function. And then we'll talk about the operations team. Now, operations team is not only people who are supporting just computer system or hardware or operating systems. Those are just the system administrators. In fact, there are also network administrators who could be involved in this DevOps venture. There could also be a database administrators if or there is an application that is being built for the database purpose. Then the database guys have to be involved. Then of course the end user within the company, the end users are the people who actually going to be using that application, so they could be part of that DevOps teams as well. So what happened is that all of these teams come together in harmony and they work together to make that DevOps team. So there could be lesser or fewer team than I have listed here, or there could be more than that, depending on the application functionality, what they are trying to achieve. In this video, we will cover the history of DevOps. So DevOps is relatively a new concept in software development and operations. With its origin in early 2000s, it emerged as a response to the challenge faced by IT organizations in delivering software quickly, reliably, and at scale. So that was the again main purpose and challenge why the DevOps was introduced. One of the earliest references to DevOps was in 2008 when Patrick Du Bois organized the first DevOps Days conference in Belgium. The conference brought together developers and operations professionals to share the ideas and best practices for improving collaboration and automation in the software development process. Then comes 2009 when John Allspaw and Paul Hamad gave a talk at the Velocity conference titled 10 Deploys Per Day, Dev and Ops Corporation at Flickr. The talk highlighted how Flickr's engineering team had adopted a collaborative approach to software development and operations that emphasized automation, monitoring, and continuous delivery. All right. Also, the term DevOps itself is believed to have been coined by Andrew Clay Schaefer and Patrick Du Bois at an Agile 2008 conference in Toronto, Canada. There are also other thought leaders such as Gene Kim, Jez Humble, and Nicole Ferguson, who have written books and conducted many research on this DevOps subject. All right, so today DevOps is seen as a key enabler for digital transformation, allowing organizations to deliver software faster and with greater reliability, while also improving collaboration between development and operations team. So once again, you're going to hear this word collaboration over and over again because the whole purpose of creating DevOps is to collaborate these two teams together so a software can be delivered in an agile manner. In this video, we will cover the benefits of DevOps. Now, there are numerous benefits of having DevOps in your environment. The few of them that I have compiled that I think that you should know, and you would know the value of bringing DevOps in your environment. So the first one is faster time to market. DevOps practices enable rapid deployment and development of software, allowing organizations to bring products and features to market a lot faster. Then we have higher quality of software. DevOps emphasizes automated testing and continuous integration, which reduces the likelihood of bugs and errors in software. So when there's no bugs, this helps to ensure that software is of high quality and meets user needs. All right, the next one is increased collaboration and communication. Of course, when there are two teams coming together, there has to be a communication that will work a lot faster. So DevOps brings together development, operation, and other teams involved in software delivery, fostering greater collaboration and communication between these teams. This will help to ensure that everyone is aligned and working together the same goal. Then improved efficiency and productivity. Automation and standard process improve the efficiency and productivity of software development and deployment. This can result in cost saving and increased revenue for organization. Then we have greater stability and reliability. So it emphasizes continuous monitoring and feedback, which enables quick identification and resolution of the issues that actually come up during this testing. This helps to ensure that software is stable and reliable and that any issues are addressed right away. All right, then moving on, flexibility and scalability. DevOps practices enable organizations to quickly and easily scale their infrastructure and software to meet changing business needs. Then we have improved security. DevOps practices such as automated testing and continuous monitoring can help to ensure that software is secure and meets regulatory compliance requirements. Then the other few of them are like reducing unplanned work and also reduces so much stress that you could have on a job when you actually don't have that type of communication and collaboration among the different teams. In this video, we will cover the importance of DevOps as an individual. DevOps is not only important to organizations, but also to individuals working in the field of software development and IT operation. So let's go over some of the reason that why it is important to individual as yourself and why you are here learning DevOps. All right, the very first thing is DevOps is the most high paid jobs as per CNBC, and Glassdoor. Because this type of skills or DevOps skills, you need to have skills in the development as well as in the infrastructure side. So that's a combination of both skills, and you need to know a lot more tools so you could go through the development life cycle. That's why it's one of the most high paying jobs. Then professional growth. DevOps practices require a broad range of skills and expertise, which allows individuals to develop their technical and non-technical abilities as well as gain experience in different areas of software and IT operations. It provides you career opportunities. So DevOps, of course, is in high demand, and individuals with experience and expertise in DevOps are highly sought by employers, offering many opportunities for growth and advancement. Then collaboration and communication. So we know DevOps is all about collaboration. So it requires a high level of collaboration and communication. Now that allows individual to work closely with other teams and stakeholders, which can help them develop important interpersonal and communication skills. Yes, when you're working together with other teams, and the communication is the key, then you will learn so much about the business communication, how to communicate in a very professional manner with other teams. Then continuous learning. DevOps require continuous learning and improvement, allowing individuals as yourself to stay up to date with the latest trends and technologies in software development and IT operation. So, as I mentioned on the first bullet point, this type of job requires you to know a lot of tools. Now, as those tool changes, the newer versions come in, you have to know the newer features offered by each and every tool. So, it's a continuous learning. Then, moving on, personal fulfillment. So DevOps offer individuals the opportunity to make a meaningful impact on the organization's success, allowing them to take pride in their work and feel fulfilled by contributing to the company's goal. So when you actually build the software and you know and you go through all the life cycle of a product development, you will feel so good inside that you have done something by following the right procedure. Then higher job satisfaction. When you go through the personal fulfillment, of course, it will provide you higher job satisfaction. So DevOps helps to reduce manual work, eliminate repetitive tasks, and automate processes. So this leading to higher levels of job satisfaction and better work-life balance. Then greater impact. DevOps enable individuals to make greater impact on their organization by delivering high quality software faster, with greater reliability, and at a lower cost. This can lead to a greater sense of purpose and fulfillment in their work. So, in summary, DevOps skills are highly valued by employers, and individuals as you who master these skills can actually enjoy a fulfilling and rewarding career in the software development and, of course, IT operation fields. While DevOps provide many benefits, but there are some potential drawbacks that organizations should be aware of. Before I start explaining the drawbacks of DevOps, let me remind you that DevOps is focused on removing the roadblocks and making the application release process a lot easier, streamlined, automated, and always accessible to users. Automation refers to techniques that minimize human efforts. While fixing issues, you can't just say to the end user, hey, please hang on for a few days. We will come back to you after we fix things for you, right? Now, I'm heading further to explain today's topic, which is about drawbacks of DevOps. The first one is complexity overload, which means the difficulty of implementing DevOps practices in organizations without having special expertise. Yes, DevOps complex tools and techniques cannot be learned instantly. You can't operate something without even learning the required skills, right? Ask yourself, can you fly a plane without getting certified qualification and expertise in aviation? No, right? Just like that, you cannot just jump into DevOps without learning the right tools. Then the second one is the skill gaps. Lately, DevOps has become really popular, but there aren't enough DevOps experts for all the jobs available. The experts that are around need to be really good at their job to work well without mistakes. Without having enough professionals, the purpose of DevOps cannot be fulfilled. Then the next one is initial investment. So for DevOps, a solid budget is required to arrange the best tools and trainings, which is not practical for small business having limited budgets. If they invest in DevOps, then the cost of their existing operation will disturb. So you can't directly implement DevOps without having strong economic resources. And when I say resources, it doesn't really mean money only. It means the right number of professional with the right expertise, tools, equipments, trainings, and most importantly, the time. Then resistant to change. Some team members are reluctant to learn innovative practices, especially when they are newly introduced. Just like we were uncomfortable wearing a mask at the beginning of COVID-19, remember? Many IT professionals who have been working in IT for a long time do not adapt to change so quickly. And of course, getting into DevOps require a lot of learning and working with so many different tools. Then we have security risks. Inefficiency or inefficiently managed tools and integrated parts make the system more prone to vulnerabilities because increased complexity demands stronger security management. You want positive outcome, right? So you also need efficient security management to protect your application from any glitches or bugs. Then we have a reliance on automation, which means in case of unusual and unexpected behavior of automation process, bugs and errors can be introduced in the system which hinders troubleshooting and debugging. It requires special experts to identify and eliminate the root cause and ensure the stability of application. So this risk seriously needs to be considered by operations team to ensure smooth application development. So yeah, it was all about the disadvantages of DevOps. I have explained to you all the pros and cons so that you can completely understand and know both ups and downs of DevOps. And remember one thing, always learn easily, not complicatedly. Hello, my future DevOps engineers. This whole section will embark into exciting practices and services that DevOps offer to aid the application release process. Some of these practices are continuous integration, delivery, deployment, situational awareness, configuration management, and so on, which we will cover one by one. All right, first, let me remind you that DevOps is a set of practices that focuses on improving collaboration and communication between software developers and IT operations teams to enable the rapid, reliable, and continuous delivery of software. You will be wondering how these practices will be beneficial for you to learn. Let me tell you that by mastering these practices, you will be equipping yourselves with a powerful toolkit that will make complex process easier for you and also smoother collaboration and innovation will be ensured. Additionally, by learning these DevOps practices, you will be stepping ahead to empower yourself with the skill set which is gaining popularity in the world of modern software development and IT operations. Yes, you heard it right. DevOps has been the center of attention since the last few years, and it is important that you understand what services it has to offer. So, what are you thinking about? Let's explore these practices together in my upcoming lectures and unlock the dream of learning complicated things in simpler ways. This lecture is about first practice of DevOps, which is called continuous integration. First, let's understand the concept of DevOps practices with the help of an example. So, it is understood that you can't get good marks in exams without doing practical efforts, right? Like your homework, taking classroom lectures, self study, writing practices, and so on. So, similarly, DevOps practices are kind of your homework or self studies that developers and operations teams do to create and release a software or application quickly with 24/7 availability to its users without any errors or bugs. Now, let's explore continuous integration, or in short, CI. First, understand the term CI, as it is a combination of two words. The first one is continuous, which refers to any phenomena that always keeps on going. The second word, integrate, means in simple terms is the process of combining or coordinating different components or systems to work together as one. Just like we create our desired objects after combining Lego blocks with each other. Now, likewise, in the process of continuing integration, all developers constantly share their newly written code in a shared space called repository. This code is automatically checked with the pre-existing codes. If there are any conflicts or errors, they are immediately fixed so that a pile of problems won't be created at the end to delay further tasks. Now, this is done automatically, which means human involvement is minimum in this process. CI is aimed at timely addressing of problems, minimizing of manual efforts, ensuring reliable and constant integration, testing and validation of code changes. In case of a successful code compatibility, the process moves toward the next step, which is deployment, which of course we will learn about deployment in the next lecture. So you can simply define CI as the automated practice of frequently combining and testing code changes by different team members. Now, this is done by various methods, including automated testing. It is the method of inspecting the correctness of a code changes of a software with the help of computers. Version control. It is practice where software teams keep the record of previous and updated versions of any application or data to keep track of changes and prevent themselves from chaos. Then comes automated building. This automatically compiles links and package code into an executable and deployment form. Then we have code quality check. It is an automated process of accessing or inspecting the quality, readability, and maintainability of your code. It helps in the identification of potential issues and ensures the compatibility of code with standardized criteria before the code is pushed into repository. All right, I have explained this process in a much simpler way as I could, and I hope that you have understood it completely. I will see you in the next lecture. This lecture is about next two practices of DevOps, which are named as continuous delivery and continuous deployment. Both are abbreviated as CD. Let's first see what continuous delivery is. It is a DevOps practice in software development that ensures software is always in its executable form, which means it must always be ready to deploy in production environment. Before a software is handed over to the end users, it needs to be automatically tested in pre-production environment, which is also called staging environment. Here, the final testing and validation of changes takes place before its deployment into live production. It's just like the final rehearsal before presenting your play in front of the audience. You can define it as the process of automatically deploying code to a staging environment where further testing can be performed. Let's say you are part of a developer's team who's working together to add a new feature into an iPhone instant messaging application. This feature, let's say we call it clear the last line. Now, let's go through the process, how the process of continuous delivery works. The first part is new feature development. Of course, we have to identify the feature. With the help of this upcoming feature, users will be able to delete the last line by pressing and holding the spacebar on the keyboard for more than 3 seconds. Now, this is the feature that will be added and it has been identified. Now, the next step is automated building and automated testing. As soon as coding of this new feature is finished, your code is taken by automated process and new version of application will be created. Here, automated testing will ensure that this newly developed feature works effectively and does not bother pre-existing feature and user experience. All right, then it gets to the staging area. In staging area, the new version will be applied where it will be tested by using it prior to its deployment in actual environment. Then comes the feedback on modification, of course. This is where you can get feedback from the users and adjust accordingly if the feature is working the way it should be. Then automatic deployment. Once everything is tested, checked, and reliably ensured, this feature will be added to the application, of course. So continuous delivery ensures that this app keeps updating more frequently with more exciting features, offering more engaging user experience and premium performance. All right, this is how continuous delivery works. Let's move on toward the next exciting practice named continuous deployment. In continuous deployment, finally, all previously tested code changes are automatically and continuously deployed to production environment. Due to the automated deployment of changes, we can save a lot of our time as software can be rapidly released with no compromise on its quality. It also reduces time for deploying new features and fixing errors. And do you know what the amazing part is? The users can enjoy exciting new features and have immediate access to updated software versions. You only have to update the app and it is good to go. Please note that it's not like once software is provided to end users and the team have no concern afterwards. No, no, no. Things don't work like this in continuous development. The process of updating features and fixing bugs never stops. Rather, it involves further monitoring and rollbacks in case of problems. That's why it is called continuous deployment. Now, let's summarize how continuous delivery and deployment differ from each other. So, in continuous delivery, automatically releases the software changes to the staging and pre-production environment for finalized testing, while continuous deployment automatically deploys these tested changes to production environment to make it quickly accessible to the end users. Hey, beautiful people. In this lesson, we will learn another important practice of DevOps, which is situational awareness. Let's first understand the real meaning of the term under the umbrella of DevOps. Situation is the current state or condition of the software related environment at a particular time, whereas awareness is your acknowledgement about the situation. So in DevOps, situational awareness is the practice of continuously observing and understanding the current state of your software system, infrastructure, and operations. It includes other different elements like system performance, error frequency, security threats, user activity, and other related information. This awareness is really crucial for spotting errors, detecting potential risk, and making informed decisions for the consistent reliability and performance of an application. Okay, another thing, the concept of situational awareness originally comes from the field like aviation and military, where operators must maintain a constant, real time understanding of many factors to make a rapid decision in complex and fast changing environment. Okay, here are some of the tools and practices that we'll go over that enhance situational awareness in DevOps. The first one is monitoring and alerting. Tools that provide real time monitoring of the systems, applications, and infrastructures and alert teams when anomalies are detected. Then we have log analysis. Centralized logging solutions that allow for searching, analyzing, and visualizing logs in real time can provide insights into system health and performance. Then the next one we have dashboards. This is a helpful approach in situational awareness. With the help of dashboarding, every activity is displayed on screen and you can visually see what's going on in the system environment. Due to this visual representation of the current state of system, bugs or issues can be conveniently identified. It's just like spotting any suspected behavior of people by watching the CCTV footage of a public cameras. Then we have postmortems and root cause analysis. When things go wrong, conducting a thorough analysis to understand the cause and then putting measures in place to prevent reoccurrence. All right, in short, situational awareness is aimed at helping DevOps teams to timely address problems, maintain system reliability, which in turn improve overall system performance and provides great user experience with minimized downtime. In the next lesson, we will explore additional DevOps practices. So, we'll see you there. In this series of DevOps practices, another crucial practice of DevOps is configuration management. Configuration management, or in short, CM, in DevOps is the process of systematically managing, organizing, and controlling software and infrastructure configuration. As always, we will break both words and go over them one by one so you could have a better understanding. The first is configuration, which is a technical description or a template of a system or an application. It includes configurations such as system settings, user preferences, network configuration, security settings, and so on. Just like setting up your mobile phone the very first time when you power it up, you will set up your language, your region, time zone, security, screen brightness, network preferences, etc. So, in other words, the parameters and options that determine how a software application operates and behaves are known as configuration of any system. Now, while management is the way to organize, control, and maintain these configurations, processes, or any activity according to your desired criteria. This configuration management practice is done by DevOps using automation tools such as Ansible, Puppet, Chef, Terraform, and so on, which, by the way, we will cover all of them later in the DevOps tools section. Please note that configuration management and automation are not the same processes. Rather, automation is used in configuration management to make procedure work quickly and flawlessly. In DevOps, configuration management is the set of practices and tools for automatically managing and controlling the configuration of software and its basic infrastructure throughout its entire development and deployment process. The configuration settings and other code changes are specified, tracked, and maintained in a systematic and consistent manner. You can also say that configuration management is used to personalize the behavior of software according to your needs. Just like you have a magic wand and you could adjust and make the software behave as you want, then it can apply to other systems over and over again. Let's see how it works. First, it defines the required state of software or infrastructure in the form of code or script. These codes are automatically read by automation tools, and these tools automatically apply the settings. The code is updated whenever changes are needed. Lastly, the job of automation tools is to make these changes compatible with the system. Now let's go over as to why configuration management is so important in DevOps. The first one is its consistency. As software gets promoted across various environments, for example, development, testing, staging, and production, configuration management ensures consistency across all these environments. Then we have reproducibility. In case of a disaster or system failure, CM allows quick recovery by ensuring that systems can be easily recreated with the same configuration. Then we have audit and compliance. CM tools can track changes and provide a history of configuration, helping in audits and maintain regulatory compliance. Then the next one is collaboration. With a shared understanding and standardized configuration, development and operation teams can work more in cooperation. In summary, configuration management is all about the automated and systematic maintenance and monitoring of software configuration and its infrastructure. Hello, in this video we will cover another fundamental DevOps practice known as infrastructure as code. It is abbreviated as IAC. In simple words, infrastructure as code is the managing and provisioning of infrastructure through code instead of manual process. Now let's describe this in more detail. First, what is infrastructure in IT? Infrastructure includes resources such as servers and networks, databases, or applications. And provisioning means to configure or set up these infrastructure resources. Now, the pre-DevOps days, the infrastructure was set up manually, one by one, which was tedious work. Now, with DevOps IAC practices, the provisioning of infrastructure is all automated by writing a code, and that is called infrastructure as code. This approach is used by software development and IT operations teams together to streamline and automate the process of delivering and managing software systems. This makes it easy to manage and automate the configuration and deployment of infrastructure. As you know, DevOps is aimed at speeding up the application development and deployment process. Likewise, infrastructure as code is kind of a helping hand for DevOps to achieve its goal. Please note that infrastructure as code always involves automation just like configuration management. So, to put as an example, suppose you want to create a new server for your application. With IAC, you will write code that will define the way the server should be set up. Same as the application code, this written code will be stored in a version control system like a Git. We will learn about Git when we go over the DevOps tools in detail. When a new server is needed for your application, you will simply run this code, and IAC tools will take care of the creation and configuration of server according to your code. This process is consistent and can be repeatable. And now you do know what the good part is. You could easily audit and modify this process whenever you need it. Some DevOps tools like Terraform, Ansible, and Puppet are commonly used in IAC tools that aid in the management of infrastructure as code. Of course, we will learn all about them later. These tools provide a way to describe or express infrastructure in human readable format, and these descriptions are automatically applied to create and maintain IT environment afterwards. Like other DevOps practices, infrastructure as code also offer multiple benefits. Let's have a look at them. The first one is consistency and faster deployment. It ensures that infrastructure is set up in the same manner each time. That will, of course, reduce the errors caused by manual configuration. Moreover, due to the involvement of automation in IAC, deployment process will speed up. Then we have scalability. When your application need to grow, you can easily create and manage multiple servers and resources with the help of IAC. In this way, the application will be able to handle more users or data. Then we have version control. As codes are stored in version control systems, changes can easily be tracked, and you can easily go back to previous setup when needed. And the last one is cost efficiency. It is cost efficient because you can turn off and delete the resources when they are not needed. That in return saves you money on cloud services and hardware that are not in use. So, in short, infrastructure as a code is a process of using code and automation for the better management and provision of IT infrastructure to make it more streamlined and reliable. Now, you're probably thinking that isn't configuration management and infrastructure as code the same thing? Let's look at the difference. Configuration management tools primarily focus on installing and managing software, such as application, system software, or middleware on existing servers. They ensure that the software is correctly configured, running as expected, and that the correct version are used. Now, infrastructure as code, on the other hand, is about provisioning and managing the infrastructure itself, like creating or destroying servers, setting up networking, and handling storage. Infrastructure as code represents the infrastructure in code form, enabling automated setup and tear down of entire environment. I will see you guys in my next lesson with another exciting topic about microservices. In this lecture, we will discuss another exciting DevOps practice called microservices. Before I jump on to explaining this practice in detail, I want you to pause this lecture for a few seconds and ask yourself, how would you describe microservices? All right, if you have broken down microservices in two words, then you will get to the correct meaning. Micro, which means tiny or small, and services refer to providing particular functions or jobs. So generally, microservices stands for smaller functions or tasks. In DevOps, microservices is a practice to develop and deploy a complex and giant application as a collection of smaller and independent parts. Here, independent part means that they work as individual micro applications. Suppose you are using an online shopping application. You viewed the catalog, put products in your cart. Now you want to check out. You are seeing payment option and you want to pay using your credit card. But what happens here that you can't select your desired payment method? So in this scenario, you can't say that the entire application is not working. or you are unable to put products in your cart because the payment method issues. Instead, you would say that this specific part of application that deals with payment pathways is not working. So, what's the actual case here? Each part of the application is working independently, even though all of them are components of one single application and they work together to complete a transaction. So now let's put this in an example so it will be a lot easier to understand in detail. Let's see how an application is built using microservices. Suppose you want to build an online shopping application that has five components: user accounts, product catalog, shopping cart, checkout, and payment methods. Now you want to build this application in less time with no errors. For this, you hire a team of 10 members and you divide it into five smaller teams, each having two members, one for development and one for operational purposes. Now, each team will work on one separate part of the application, like one team for user account, one for product catalog, and so on. In this way, as soon as each component is developed, it will be individually tested and deployed in production environment. In case of any error in its performance, you won't need to fix the whole application. Rather, that problematic part of that application will be fixed separately. These components will communicate with each other using different pathways, but any failure in functioning of one won't affect the other. So all these components are part of one big application, but each of them is providing its own services independently. This is how microservices work in simple ways. Variety of tools by microservices are used. Some of them are like Docker's, Kubernetes, Git, GitHub, and all of them will be covered later on. Let's see what kind of advantages microservices offer to the software teams. The first one is self-contained and independency. Each component of application provides its own specific services and works separately. Due to this, it is easy to identify potential problems, and only that part of the application needs to be fixed, not the whole application. Due to this independence, you can use different languages to develop different components. Yes, you don't have to develop the entire application using one language. You use different languages for different component or different pieces of that application. The next one is quick processes. When teams separately work on smaller components of application rather than the entire application, the development, testing, and deployment process gets speedy. Then scalability. Let's say your application gets popular and now you want to add more product categories. So for this, you only have to make changes to the product catalog part only. Better fault tolerance is the next one. And if one part fails in this, that does not mean that whole application stop working. Instead, remaining part of the application will still work correctly, right? That's why we have better fault tolerance. So in summary, using microservices as a DevOps practice means that you are breaking a software into smaller and manageable parts. This will allow teams to work quickly while ensuring better quality and making the software more adaptable to changes and improvements. In this way, both the quality and application release time won't be compromised. Okay, it was all about microservices. I hope you have understood it well. I will see you in the next lesson. Hi, welcome back to another lesson of DevOps practices. Today we will learn about practice known as monitoring, logging, and feedback. Let's see their concept in the domain of DevOps. In DevOps, monitoring means to closely observe the performance of your software and the infrastructure. It is done to make sure that software is working in the way it is designed. DevOps emphasizes continuous monitoring of software and its infrastructure to quickly identify and resolve issues that arise. Logging refers to making a record of software performance and what kind of services it offers. It's just like keeping a journal of a software with all the history of its events in application development and deployment journey. All right, now the feedback normally refers to the response. In DevOps, feedback loops are used to gather inputs from users, team members, and stakeholders to continuously improve the software. It aims to learn from mistakes after collecting data from different processes, user experiences, and feedback. Monitoring, logging, and feedback practices are very important in DevOps. They work together to manage the development and deployment of software to make it more streamlined, improved, and reliable. Let's break down these processes further and see how they work and which benefit they offer. Going back to the first one, our monitoring. Monitoring uses different tools and automated systems to continuously track and collect data on various aspects of software and infrastructure, such as performance matrix, error frequency, and resource utilization. Some commonly used monitoring tools are Prometheus, Grafana, Nagios, Datadog, and New Relic. Monitoring provides following advantages. Early issues detection. With the help of monitoring, some issues like slow response time or high server loads are identified and resolved as early as possible. So it helps in proactive problem solving. Scalability. Monitoring enables you to keep an eye on the scalability of an application. In this way, you can ensure that either your application or system can handle increasing loads without compromising on its performance. Then we have data driven decision making. Monitoring data provides a better understanding of your system's behavior and its performance trends, enabling teams to take informed decisions for optimization. Then move on to logging. Logging involves recording actions, events, and errors of software and infrastructure in the form of log files or databases. These logs contain valuable information about systems activities and user interactions. Logging uses different tools that include ELK-Stack, Splunk, FlintD, Graylog, and Sumo Logic. It offers multiple advantages that include troubleshooting. Whenever an issue arises, log data are analyzed to spot errors. As a result, easier and fast troubleshooting is performed to resolve the issue. Compliance and auditing. Logging helps in compliance with regulations and provides an audit trail for security purposes. Historical analysis. As log files keep the history of all changes made to the software, which helps in identifying patterns, trends, and deviations. All these can be used to make decisions based on data analysis to improve the system performance. Then moving on to the last practice, feedback. Feedback is obtained using various methods like user survey, bug reports, peer reviews, and team discussions. Some of you may or may not have filled out user survey of some applications. In this way, teams can have insight into user experience, their concerns, and suggestions. Feedback uses tools like Jira, Slack, GitHub, User Voice, and Trello. Now let's look at some of the advantage of feedback. User-centric improvements. Feedback helps to understand better user needs and performance, which eventually help in making user-focused improvements and new feature additions. Then continuous improvement. With the help of feedback loops, teams keep revising their processes that result in continuously identify problematic areas, fixing issues, and making improvements. Then another advantage of feedback is quality assurance. Feedback can identify defects and usability issues in early stages of development life cycle. That of course results in high quality software. In short, all these practices work together to ensure all-time premium performance, reliability, and flawlessness of any software application with the aim of providing continuous improvements and better user experience. Hey, welcome back to the last lesson of DevOps practices named as collaboration. You all have been hearing this term since the first lecture of DevOps. Generally, collaboration referred to a collective work where people or groups working together to achieve a common goal or objective. Likewise, in DevOps, collaboration is a set of practices that aims to improve communication and cooperation between development, IT operations, and other teams to deliver software more reliably, efficiently, and in time-saving manner. Communication and collaboration are essential to ensure that everyone is aligned and working toward the same goal. You will be thinking why collaboration is so important and why DevOps was actually needed. Let me tell you that in pre DevOps days, both development and IT operation teams used to work in isolated ways, and developmental teams were not aware of the requirement or processes needed to deploy an application, and same was the case with operation teams. They used to face problems due to this lack of communication and collaboration between them, and that always resulted in multiple issues. Fixing those problems used to take a lot of time, and that eventually delayed the application release process. So then, of course, to overcome this problem, there was a need for the collaborative work so that all members should work together to achieve the common goal of your organization. That's why DevOps was introduced to build collaboration and communication between teams, and it made processes speedy using automations, of course. Collaboration involves a combination of communication, coordination, and collaboration tools that facilitate teamwork and information sharing among team members. These tools include Slack, Asana, Bitbucket, GitLab, Git, Microsoft Team, and so on. Let's see how collaboration in DevOps works. Cross-functional team is the first one in line. DevOps encourages the formation of cross-functional team that includes members from various disciplines such as developers, operation, quality assurance, security, and business stakeholders. These teams work together on a shared goal, and that goal is to deliver high quality software or application. Then shared goals and objective. The purpose of the collaboration is that teams have a common understanding of goals and objective of the software development and delivery process. Team align their efforts to achieve their determined aim, which are faster delivery, improved reliability, and enhanced customer satisfaction. Then communication. Effective communication is crucial in DevOps collaboration. Teams should establish open and transparent channels for communication purposes so they can share information, updates, and concerns with each other. Then automation and tooling. Automation and DevOps tools facilitate the collaboration. Automation reduces manual, error-prone tasks that DevOps tools enable teams to collaborate on code integration, testing deployment, and monitoring. Then the last one is the security integration. Through collaboration, security is integrated into DevOps processes. Security teams work with the development and operation teams to identify and address security vulnerabilities, and compliance requirements through development lifecycle. Furthermore, collaboration is essential in continuous integration, delivery, deployment, feedback loops, and some other development practices. In summary, collaboration is aimed to replace old ways of isolated work patterns by mutual work environment with shared goals and aligned efforts between teams that of course aid DevOps to achieve its goal. So now DevOps practices come to their end. I will see you in the next section.